Can you believe it? Humans have managed to dig a tunnel 40 stories deep beneath the sea without a single leak, build a railway across a continent in bitterly cold, frozen wastelands, and construct a cosmic machine underground that is colder than outer space itself. The following 10 megaprojects are widely recognized as having hell-level difficulty. They cross mountains and oceans, reach into space, and root themselves deep underground. Only after seeing them do you truly understand what it means for engineering to defy fate itself. Number 10. The Leaning Tower of Pisa Stabilization Project, Italy. As one of the most iconic landmarks of Italy's Piazza dei Miracoli, the Leaning Tower of Pisa began construction in 1173. From the very start, uneven soil beneath its foundation caused the tower to tilt southward by the time it reached the third floor. By the late 20th century, the tilt angle had reached 4.5 degrees, with the top displaced by nearly 4.5 meters from the central axis, roughly the height of 1.5 stories. Any further tilt could have led to collapse at any moment, making its posture correction a global engineering headache. The greatest challenge was that conventional building repair methods could not be used. The task was more like performing corrective surgery on a 100-year-old patient. The tower needed to regain some verticality without causing any structural damage. The engineering team adopted an ingenious solution. They carefully removed small amounts of soil from the north side of the tower, like gradually removing support from the leaning direction, allowing the tower to slowly tilt back under its own weight. At the same time, 660 tons of lead counterweights, equivalent to the weight of about 300 family cars, were placed on the north side to precisely control the speed of correction, ensuring the daily movement did not exceed 0.1 millimeters, slower than the growth rate of a fingernail. In addition, a comprehensive monitoring system was installed to track the tower's condition in real time, guarding against sudden risks, such as groundwater fluctuations or soil loosening. After years of effort, the tower's verticality was significantly improved, with the tilt reduced to 3.9 degrees. It is now expected to remain stable for another 250 years, successfully solving the leaning problem while fully preserving the historical appearance of this 1,000-year-old monument. Number 9. The Panama Canal Original Construction and Expansion Project, Panama. The Panama Canal is like a waterborne shortcut connecting the Pacific and Atlantic Oceans across the Isthmus of Panama, saving ships tens of thousands of kilometers in travel distance. However, the difficulty of its construction and later expansion was comparable to cutting a super waterway through a tropical jungle. When construction first began in 1904, workers had to battle dense rainforests, muddy swamps, and volcanic rock as hard as stone. Combined with extreme heat, humidity, and swarms of mosquitoes, diseases such as malaria and yellow fever became invisible killers, claiming the lives of tens of thousands of workers and repeatedly halting progress. It took 10 years before the canal finally opened to traffic. In the 21st century, to allow much larger container ships, reaching the height of roughly 10 stories, to pass through, the canal underwent a major expansion. This challenge was even greater than the original build, akin to replacing an old doorway in a house. Not only must the old door be removed, but the frame and foundation must also be reinforced and widened. The biggest difficulty during expansion was the canal's soft, muddy base, which was highly prone to subsidence. To solve this, engineers constructed massive caissons weighing up to 30,000 tons each, comparable to the weight of an aircraft carrier, and had to assemble them with extreme precision in narrow, heavily trafficked waterways. At the same time, they needed to protect surrounding rainforests and rare wildlife to avoid destroying their habitats. After 9 years of effort, the expansion was completed, dramatically increasing the canal's capacity and creating a cross-century engineering miracle. Number 8. The Channel Tunnel. The Channel Tunnel is like a super subway hidden beneath the sea, connecting Dover in the UK and Calais in France. It spans over 50 kilometers, with 38 kilometers running under the seabed. At its deepest point, it lies 115 meters below sea level, roughly the height of a 40-story building. Digging a tunnel at such depth is no easier than carving a passage inside an eggshell, without cracking it. The seabed geology varied dramatically. Some sections were as fragile as crumbled biscuits, while others were saturated with high-pressure water layers. Any mistake could lead to collapse or seawater flooding, with catastrophic consequences. Construction teams from both countries began digging simultaneously from opposite sides, like two people walking toward each other from the ends of a long corridor, needing to meet with an error margin of less than 10 centimeters. Given the technology of the time, this was like walking blindfolded across a sports field and still hitting a tiny target. The cold, high-pressure environment also placed enormous strain on workers and equipment. Specialized ventilation and drainage systems, like giving the tunnel lungs and plumbing, were essential to prevent gas buildup and water intrusion. After 6 years and the efforts of nearly 10,000 workers, the tunnel was finally completed, breaking the natural barrier of the English Channel. Since then, passengers can travel by train between Britain and France beneath the sea, and the project has provided invaluable experience for undersea tunnel construction worldwide. Number 7. The Three Gorges Project, China. The Three Gorges Project is a super dam on China's Yangtze River, located in the Xiling Gorge. It serves flood control, power generation, and navigation, making it the largest water conservancy project in the world. Building it was like constructing a 2,300-meter-long, 185-meter-high fortress wall across the Yangtze River, and ensuring it would never fail. There were three main challenges. First, nearly 28 million cubic meters of concrete had to be poured, enough to fill about 10,000 standard swimming pools. Such a massive volume generates heat during curing and cools at night, making it prone to cracking, like pouring cold water into hot glass. Engineers had to precisely control temperature to prevent fractures. Second, the dam's foundation geology was extremely complex, like a cracked base. To prevent the dam from sliding under immense water pressure, engineers had to reinforce the foundation, essentially giving the dam a pair of anti-slip shoes. Third, enormous turbine generators had to be built, each with a capacity of 700,000 kilowatts, enough to power a mid-sized city. These supermotors needed to operate reliably without failure. Over 17 years, engineers overcame challenge after challenge, setting hundreds of world records. The dam stands as both a symbol of China's engineering strength and a model of humanity's ability to harness nature. Number 6. The International Space Station Multinational Project. The International Space Station is like a superstructure floating in space, orbiting 400 kilometers above Earth, about 10 times higher than typical cloud layers. Built jointly by 16 countries over 12 years, it serves as both a human habitat and a scientific research platform in space. Its construction difficulty was akin to assembling building blocks in midair while keeping the structure perfectly stable. The greatest challenge was not technical complexity alone, but coordinating 16 nations to work in complete harmony. It was like assembling a massive puzzle where every piece had to match exactly in size, shape, and interface, with zero tolerance for error. The station weighs 420 tons, equivalent to 420 family cars, and consists of over 100 modules launched individually into space and assembled with docking precision within 1 millimeter. This process was like throwing a needle from 100 meters away and threading it through the eye of another needle. Additionally, the station required a complete life support system, essentially space-grade air conditioning, water purification, food storage, and radiation shielding, like wrapping the station in a bulletproof vest. Its completion unified global spaceflight efforts and pushed humanity's exploration of the universe further forward. Number 5. The Hong Kong-Zhuhai Macao Bridge, China. The Hong Kong-Zhuhai-Macao Bridge stretches 55 kilometers, comparable to the distance from a city center to its suburbs. Integrating bridges, artificial islands, and an undersea tunnel, it resembles a giant dragon crossing the Ling-Dingyang Sea. Its construction difficulty was like building a highway in the open ocean while crossing one of the busiest shipping lanes on Earth. There were three major challenges. First, a 6.7-kilometer undersea tunnel had to be built in waters over 40 meters deep, about the height of a 13-story building, while avoiding busy shipping routes. Installing the immersed tunnel segments required extreme precision, like sealing a massive underwater box without a single gap. Second, the area is frequently struck by typhoons, with wind speeds reaching level 16, powerful enough to uproot trees. The bridge had to remain stable under such extreme conditions. Third, construction had to protect the habitat of the endangered Chinese white dolphin. After 9 years of effort and innovation, the bridge became a symbol of national pride and a major leap forward in offshore engineering technology. Number 4. The Gotthard Base Tunnel, Switzerland. The Gotthard Base Tunnel is a super underground railway beneath the Swiss Alps. It stretches 57 kilometers, with 35 kilometers underground, and reaches depths of 2,300 meters, about 77 stories below the surface. Digging such a tunnel is like carving a perfectly straight passage through a solid mountain without causing collapse. The challenges were immense. First, geological conditions varied drastically, from rock as hard as steel to layers as fragile as shattered glass, along with high-pressure water zones. Rock bursts could occur suddenly, like underground earthquakes. Custom tunnel boring machines, giant steel armadillos, were designed to adapt in real time. Second, underground conditions were extreme, with temperatures reaching 40 degrees Celsius and humidity near 100%, like working inside a massive sauna. Advanced ventilation and cooling systems were essential. Third, tunneling from both ends required meeting precisely at depths over 2,000 meters underground, with an error of less than 5 centimeters, like two people in total darkness walking toward each other and shaking hands. After 17 years and the efforts of nearly 3,000 workers, the tunnel was completed, dramatically reducing rail travel times across the Alps and becoming Europe's underground artery. Number 3. The Trans-Siberian Railway, Russia. The Trans-Siberian Railway is Russia's super rail artery, stretching from Moscow to Vladivostok for 9,332 kilometers, twice the distance from China's northernmost to southernmost points, and crossing 8 time zones. Traveling its full length by train takes an entire week. Construction began in 1891 with very limited technology. The challenges were overwhelming. First, the climate was brutally harsh, with winter temperatures dropping to minus 50 degrees Celsius. Steel became brittle like glass, equipment failed, and workers faced constant frostbite risks. Second, the geology was extremely complex, with countless rivers, lakes, swamps, and vast permafrost regions. Permafrost behaves like frozen concrete in winter and mud in summer, causing track deformation and subsidence. Engineers had to constantly reinforce the railbed. Third, manpower and resources were scarce. Hundreds of thousands of workers were mobilized, including many Chinese laborers, and countless lives were lost to exhaustion, cold, and disease. After 25 years, the railway was finally completed, strengthening Russia's control over Siberia and standing as a testament to humanity's ability to conquer nature's extremes. Number 2. The Suez Canal, original construction, Egypt. The Suez Canal is Egypt's super maritime corridor, linking the Mediterranean Sea and the Red Sea over 193.3 kilometers, equivalent to about 2,000 football fields end to end. It is one of the world's busiest shipping lanes, yet its original construction was like digging a giant canal through desert and swampland by hand. Construction began in 1859 with no heavy machinery, relying entirely on manual labor. The challenges were immense. First, geology varied between hard rock and soft sand that collapsed easily. Second, the climate was brutal, with summer temperatures reaching 50 degrees Celsius, extreme drought, and severe water shortages, turning the work site into a giant furnace. Third, labor conditions were harsh. Nearly 1 million workers were involved, many under forced labor, with insufficient food and rest. Countless lives were lost to exhaustion, disease, and hunger. After 10 years, the canal finally opened, transforming global trade by linking Europe, Asia, and Africa. Number 1. The Large Hadron Collider. The Large Hadron Collider is a super scientific instrument buried 100 meters underground on the Swiss-French border. Its main ring is a 27-kilometer circular tunnel, like a giant underground racetrack, designed to accelerate particles and explore the origins of matter. Building it was like creating a machine capable of simulating the Big Bang, with extreme precision requirements. There were 3 core challenges. First, achieving ultra-low temperatures. The tunnel contains 1,232 massive magnets, each 15 meters long and weighing 35 tons. They must be cooled to minus 271.3 degrees Celsius, colder than outer space itself, using the world's largest cryogenic system with superfluid helium. Second, achieving extreme collision precision. Protons are accelerated to near light speed, and 2 beams must collide at specific points with accuracy comparable to firing 2 needles from 10 kilometers away and making them meet mid-air. Third, handling massive data volumes. The LHC generates data equivalent to millions of movies every second, requiring hundreds of computing centers across 42 countries to process it together. Built by tens of thousands of scientists from over 100 countries, the LHC has driven revolutionary breakthroughs in humanity's understanding of the universe. From undersea tunnels to space stations, from the salvation of a leaning millennium-old tower to the exploration of the universe's origins, these 10 hell-level megaprojects are far more than steel and concrete. They are medals of humanity's struggle against limits and its relentless drive to surpass itself. Forged through freezing cold, crushing pressure, and extreme temperatures, and fueled by the efforts of millions over centuries, they turned the impossible into reality.